Hello students, myself Mehul Kodia from LJIET Institute of Engineering and Technology. So in last session we start a new chapter, that is curves and surfaces, and in last session we discussed two theory. First one, that is curves representation, and second one, that is classification of curves. So in today's session we have to discuss one more theory, that is parametric representation of line. Okay. So what is parametric representation of line? So first you all know what is the equation of straight line. Equation of straight line, that is y is equal to mx plus c, where m indicates slope of the line. You can find slope of the line using equation m is equal to delta y upon delta x, or m is equal to y2 minus y1 upon x2 minus x1. In equation of straight line, y is equal to mx plus c. C indicate it is the distance between intersection point of line on y-axis to the origin. Okay. So that distance indicate the value of C. Value of C is constant. Okay. So a line can be represented in parametric form by an input of two endpoints. If you want to draw a straight line, at that time the required data is two endpoint of line, two endpoint coordinates of line, or by one point and length and direction. If you want to draw a straight line, so if you want to draw, so at that time the minimum data required, that is two endpoint, and the second option is if you have only one point but you have a length of line, and if you have a direction of line, at that time you can draw a straight line. Okay. Besides this, modified and filter can be used to represent this line. The two important methods of establishing equation for line are considered. Okay. So now we have to derive equation of parametric equation of line. A line connecting two endpoints in parametric form, having the value of parameter u as a 0 and 1 at the endpoint. Suppose if we have a one straight line, that is P1, P2. P1 is the first endpoint of the line and P2 is the second endpoint of the line. So in that case we have to consider at P1 point value of u is equal to 0, and at P2 point value of u is equal to 1, and in between P1 and P2 value of u is in between 0 to 1. Okay, so this consideration we have to take on. So there is a one tangent is also there, P1, P2. So P1 at P1 point u is equal to 0, at P2 point u is equal to 1. Now we have to consider one point P on the line, clear, and at that point value of u consider as a small u, clear. At that, because we have to derive one equation, that's why we select randomly any of the point on straight line, and in that point we have to consider value of u as a small u. Okay. So we already know that value of u on the line, that is 0 less than u less than 1, means value of u between 0 to 1. Okay. Now based on this figure we have to derive one relation between P1, P2 and distance of u. Clear? That's why we have to derive one relationship between them. Okay. So this is the one diagram. P1 at P1 u is value of u is equal to 0. You can see in this figure we have point P2. Value of u is equal to 1, that we have to consider. Now randomly we select one point on the line, that P, and at point P we have to take value of u is as a u. And the tangent vector, yeah, now you all know how to find tangent vector. If we have a line P1, P2, at that time if you find P2 minus P1, that indicate the tangent vector of line. Okay. So this is the simple diagram. Now we have to use a relation and find out the equation of the parametric equation of line. Consider a line between two given endpoint P1, x1, y1, z1 and P2, that is x2, y2, z2 as shown in figure. The position vector for these 2 points would be P1 and P2. Consider any point P, x, y, z on the line P1, P2. Clear? We have to consider any of the point as a P, and coordinate of that point P, that is x, y, z. Next, let parametric system be introduced such that the point P is represented by parameter u, such that is value are 0 and 1 at endpoint P1 and P2 respectively. Clear? Now you all know value of u at point P1, that is 0, and value of u at point P2, that is 1. Next, from triangle OPP. Clear? From triangle OPP1, we can express the vector between endpoints P1 and P as P minus P1. If you want to find vector of any of the point, at that time you have to subtract this point. Okay. This vector represents the parameter u. The mapping between the Cartesian and parametric space can be done by the following relation. Now we have to derive relationship between parametric space and the Cartesian system, like this. First one, this is the diagram, already we discussed. Now based on this diagram, distance of P from P1 in Cartesian space, in denominator you can write distance of P from P1 in parametric space, okay, is equal to endpoint length in Cartesian space, in denominator endpoint length in parametric space. Okay. So in Cartesian space we have to use value of in terms of P, P1, P2, but in parametric space we have to use value as a u, 0, 1. Okay. So distance of P from P1 in Cartesian space. So distance between P and P1, that is, if we have to consider that is P minus P1. In denominator, distance of P from P1 in parametric space. So distance between P and P1, that is small u. Already we consider that distance. So P minus P1 upon u is equal to endpoint length in Cartesian space. Now first part, that is P1, last part, that is P2. So how we can find the length, that is P2 minus P1, that indicate the length of the line. Okay, so P2 minus P1 in denominator, endpoint length in parametric space. Now value of u is 0 in first point and value of u at last point P2, that is 1. So what is the length of line in parametric form? That is 0 to 1. So what is the length? Indicate 1. Okay, because value of u at first endpoint, that is 0, and endpoint, that is 1. So length of line in parametric form, that is 1. So you have to put over here 1. So P minus P1 upon u is equal to P2 minus P1 upon 1. This equation we derive based on the diagram, based on the fundamental of triangle. Clear? Now in this equation we have to do some modification, like P minus P1 is equal to u into P2 minus P1. Now we have to use as a P as a subject of the equation. At that time the equation converted in the form of P is equal to P1 plus u, P2 minus P1, where 0 less than or equal to u less than or equal to 1. Value of u must be between 0 to 1. Okay, so this is the parametric equation of line. P is equal to P1 plus u, P2 minus P1. This is the parametric equation of line, and we have to use this equation to solve some numerical based on parametric equation of line. Okay. Now this equation represents the vector equation. P is equal to P1 plus P2 minus P u into P2 minus P1. That is the in vector form. Now we have to convert that equation into coordinate like this. Parametric form in scalar form, it can be written as x is equal to x1 plus u, x2 minus x1. Y is equal to y1 plus u, y2 minus y1. And z is equal to z1 plus u, z2 minus z1. Where 0 less than u less than or equal to 1. Okay. So parametric equation of line, that is P is equal to P1 plus u, P2 minus P1. But if you want to write down parametric equation in coordinate form, then you have to write down like this, x in the form of x, y and z. Okay. Any point on the above line or its extension can be found by substituting the value of parameter u. The tangent vector of line would be represented by P dash is equal to P2 minus P1. That already we discussed that. How to find tangent vector. So how to find tangent vector? P dash is equal to P2 minus P1. Okay. Now last thing, The length of line and direction vector n can be calculated using the following equation. Now you already know that what is unit vector, how to find unit vector. So what is the equation of unit vector? Unit vector is equal to vector in denominator magnitude of vector. Okay, so this is the equation of the unit vector. So how to find length if we have two coordinates like x1 y1 and x2 y2? Then how we can find the length of line L is equal to underscore x2 minus x1 square plus y2 minus y1 square. Clear? That equation already you learned. Okay. So length L is equal to magnitude of P2 minus P1, and what is the equation of magnitude of P2 minus P1? That is underscore x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. That is the equation of the length of the line. And what is the equation of the unit vector? So unit vector n is equal to vector, means tangent vector P2 minus P1 in denominator length of line. Length of line or magnitude of line, both these things are same. Clear? So this is the parametric equation of line. Now we have to discuss, or we have to solve some numerical based on parametric equation of line. If you want to solve numerical based on parametric equation of line, at that time you have to remember only one equation. Which equation? P is equal to P1 plus U in bracket P2 minus P1. Clear? Where value of U, that is 0 less than or equal to U less than or equal to 1. If value of U is in less than 0, means in minus, at that time that point not consider on the line. Clear? Any of the point consider on the line if value of U in between 0 to 1. Okay, that thing you have to remember that. If value of U is greater than 1, at that time that point is not on the line, but if you extend straight line in a positive direction, at that time you can find the value of U is greater than 1. So and you have to remember equation of find out the length of the line and unit vector. So in next session we have to solve some numerical based on parametric representation.